My dear children, welcome back to your favorite mathematics class. Yesterday we have started new lesson chapter 3 trigonometry. Okay, yesterday you have seen the introduction. What is trigonometrical functions, sin theta, cos theta, tan theta, and different types of angles, two types of angles, positive and negative angles, and straight angle. Like that we have discussed about different types of angles in the previous class. Okay, today let us move to the next section. Here we have two types of measuring angles. One is degree measure, the other is radians. Degree measure you have already studied in previous classes, 60 degree, 30 degree, like that. There is a measurement for angles. There is a measurement for angles that you have studied, 60 degree, 120, using protractor, how to measure the angles. Now here there is another method for measuring angles, that is radians. And let us study what is the relation between degree and radians. Okay children, let us move to DG.
Radian. We know how to measure an angle in degree. However, there are other ways of measuring an angle too. One such way is to measure the angle in radian. In scientific and engineering calculations, the usage of radians is more prominent than degrees. Do you know the meaning of angle 1 radian? Let us find out. Consider a circle with center O and radius R. Now draw two line segments OA and OB, representing the radius of the circle, such that the length of the arc AB is equal to the radius of the circle. The angle AOB so formed is called the angle of 1 radian. Thus, in a circle of radius r, an arc of length r subtends an angle of 1 radian at the center of the circle.
Here is an example of angle 1 is to 1 by 2 radians measure when the angle is measured clockwise and anti-clockwise.
If theta in radians is the angle subtended at the center of the circle of radius r by an arc of length L, then theta is equal to L upon r, or L is equal to r theta. Consider the unit circle with center O. Let A be any point of the circle. Consider OA as the initial side of an angle. Then the length of an arc of the circle will give the radian measure of the angle which the arc will subtend at the center of the circle. Consider the line PAQ, which is tangent to the circle at A. Let the point A represents the real number 0. AP represents the positive real number and AQ represents the negative real number. If we rope the line AB in the anti-clockwise direction along the circle and AQ in the clockwise direction, then every real number will correspond to a radian measure, and conversely. Thus, radian measures and real numbers can be considered as one and the same. Circumference of the circle is equal to 2 pi r in radian measure. The angle subtended by the circle at the center is equal to 2 pi radian. In degree measure, the angle subtended by the circle at the center is equal to 360 degrees. Therefore, 2 pi radians is equal to 360 degrees, or pi radian is equal to 180 degrees. Using the value of pi, we get radian is equal to 180 degrees upon pi, which is equal to 57 degrees 16 minutes approximately. Also, 1 degree is equal to pi upon 180 radian, which is equal to 0.01746 approximately.
Note that when an angle is expressed in radian, the word radian is frequently omitted. For example, we know that pi is equal to 180 degrees and pi by 3 is equal to 60 degrees. Hence, they are written without using the word radian. Here we see the formula which converts a radian measure of an angle into a degree measure of an angle. We also have the formula which converts a degree measure of an angle into a radian measure of an angle. Let us now see some common degree and radian measures. Here we have the degree and radian measure of some common angles such as 30, 45, 60, 90, 180, 270 and 360 degrees. Let us now solve some examples related to the degree and radian measure of an angle. Express the angle 35 degrees and 15 minutes in radians. Solution. We know that 60 minutes is equal to 1 degree. Hence, 1 minute is equal to 1 by 60 part of a degree, or 15 minutes is equal to 1/4 of a degree. Hence, 35 degrees and 15 minutes can be written as 35 and 1 by 4 degrees. Now we know that 180 degrees is equal to pi radians, or 1 degree is equal to pi upon 180 radian. Hence, 35 and 1 by 4 degrees can be expressed in radian measure in the following way, and is equal to 47 pi upon 240 radian. Let us find the correct answer for the given question. Pi upon 15 radians in degree measure is equal to A. 45 degrees, B. 60 degrees, C. 12 degrees, or D. 15 degrees. Solution. We know that pi radians are equal to 180 degrees, or 1 radian is equal to 180 over pi degrees. Hence, pi by 15 radians can be expressed in degree measure in the following way, and is equal to 12 degrees.